differential equations. Given that ln x show that dy dx, so first of all, we're going to need the MF19 formula for the derivative of ln x. Ln x becomes 1 over x, so that's what we use here. This is the y. The y prime is 1 over the argument of the logarithm, so it's going to be 1 over ln x. But we need to use the chain rule, so we're going to need to multiply by the derivative of the argument. So since the argument is not a simple x, the argument here is ln x, we're going to need to use the chain rule. We multiply by the derivative of ln x, which is again 1 over x, and so we get what we need to prove. Now solve differential equation. So this is the original equation, so just like this, I'm rewriting, and we need to move the terms now. So we're moving the x ln x to the right, so we subtract x ln x from both sides, and then we need to separate the variables, so we multiply both sides by something or divide by something, so we get everything with x on one side, everything with t on the other side. So after we multiply, we cancel out, so we have only 1 over x ln x dx on the left, and on the right we cancel out, we have minus 1 over t dt on the right. So now we're ready to integrate both sides. So that's how we solve differential equations, by integrating, not differentiating. So for the integral of 1 over x ln x, we use the answer to the previous part. So previously we know that if the y is ln x, the dy dx is 1 over x ln x, which means the integral of this guy is ln x. That's why the integral is ln x using the previous part. And for the integral of 1 over t, we use this MF19 formula. 1 over x becomes ln x, so 1 over t becomes ln t. Still we have the minus, just rewrite. And don't forget to add the constant of integration on one side. Now we have the general solution of the differential equation. To find the particular solution, we're going to need to plug in the x and t value. X equals e, t equals 2. So we replace the x with e and the t with 2, and we can find the value of the c. So ln e is 1, just use your calculator, and ln 1 is 0. So this means the c is ln 2. So now we have the particular solution with the c being ln 2. And if you read the question here, we need to find x in terms of t. So we have to rearrange to get x in terms of t. We can start by combining the logarithms. This is basically a subtraction. So we can combine this subtraction of two logarithms into one single logarithm, but we divide the arguments. So 2 divided by t. And since we have ln on both sides, we can do e to the power of, so that we cancel out the ln basically. So we have only the argument, which is ln x, and 2 over t on the right. And we do e to the power of again. Again, we cancel out on the left. We have only the argument, which is x. And on the right, we have e to the power of 2 over t. So this is the final answer. State what happens when t tends to infinity. So previously we know this is the equation, and t tends to infinity means the t is something really big. So you can use your calculator like this, just plug in something really big for t, something positive and big like 99999. If you get decimals, just add or subtract the add or decrease the number of nines until you get something exact and not in decimals, and you should get 1. Alright, I'll see you again next time.